Section 1 is always a buffer solution because you only have the weak acid and its conjugate base. That's what a buffer is. So in titrations with weak acid, strong base, this section right here is always called the buffer section. So here is a buffer because of this ice table. You have the weak acid and its conjugate base. It's not a great buffer because you have more moles of acid than conjugate base, but it's still by definition a buffer because that's what it is, a weak acid and its conjugate base. So now I need you to start using your brain here. Why does that make sense? Look at the shape of the graph. Or a curve. The curve. How is the curve different here from here?
Line versus up.
It's a line versus up. Okay, it's flat here,
Yeah.
vertical here, or horizontal. Okay, so why does that make sense? That's where a buffer is. What do buffers do? Resist pH changes. So does it make sense the pH doesn't change?
Yeah.
It should. I hope so. So I'm trying to make that connection. That we learned what a buffer did. Now this kind of proves it. This shows it. That in the beginning of all titration experiments, it's a buffer scenario, but mainly we're going to focus on weak acid, strong base. Here's why. You have your conjugate base and your weak acid. So the buffer doesn't cease to exist until that pH starts to go up. And that's because you won't have both of these ions anymore. Or not ions. You won't have this ion and this molecule. Once one of these goes away, then obviously you can't have a buffer anymore. Right? So, again, it's like the pKa stuff the other day. I, in the past, haven't done a good job stressing this or explaining it, so I'm trying to do that right now with you guys, that this is the buffer scenario because you have both species. Okay, so how do we figure out the pH? Do we have the concentration or moles of any ion that will give us the pH? In other words, can I take the negative log of this number and get pH? Can I take the negative log of this number and get pH?
No.
No, even if I turn it into concentration, I can't do that. There's only two ions I can take the negative log of. What are they? H plus or OH minus. That's it. So when you're doing these titrations, weak acid, strong base, you cannot get your pH until you do an ice table that produces a number with an H plus or OH minus. So what does that mean? You have to do another ice table.
No.
This isn't going to work.
No.
So now it's a buffer problem. You could also do the Henderson-Hasselbalch equation, right? But I'm gonna show you another ice table. All right. So let's see here. We got 0.0. Just making sure I got everything. 0.004, 0.001. Okay. So now, what's gonna happen inside that flask? Hold on a second. Hold on a second.
And make H plus.
Okay, do me a favor. Use the Henderson-Hasselbalch equation first. Everybody do that. And then I will do the ice table after we do that. So use the pH equals pKa plus the log of A minus over HA. So there's your A minus, there's your HA. And tell me what you guys get. Because I think I'm going to do it different this year, actually. If this makes sense to you guys and you're good, I'm not going to show you this next ice table because it gets a little confusing.
Oh, not really. PJ plus the one.
So use that Henderson-Hasselbalch equation and solve for pH.
I mean,
The Ka, yeah. I gave you the Ka, right?
Yes.
you good?
Yeah, 1.8 and something -5.
Yep, I'm gonna do it this way this year. I think this is gonna be easier for you guys. So, I'm not gonna do any more ice tables. So, the way we're gonna do these titration problems, and you can do this on your homework too, is if the buffer is present, just use the Henderson-Hasselbalch. So, anytime you're in that flat region and you have both parts of the buffer, just use that equation and that'll work every single time. There is another ice table we can do. I'm not gonna do it. Because just from experience, the next part of this it confuses the crap out of kids, and I don't want to do that because we've already done this. If you have a buffer, use that equation, and then we're going to move on with the rest of this. Okay. What'd you guys get?
4.14.
So this was 0.001, this is 0.004. Now, technically, you're supposed to convert this to concentration,
I knew it.
but you don't have to. I always tell kids, just convert it anyway, but why don't you have to?
But it's the same. As long as you keep it the same.
Right, in other words, it's because it's a ratio. Who said that? Yeah, so if you do 0.001 divided by 0.004, right, you take the log of that, it's the same thing as doing 0.001 over 60, I'm sorry, what is it? How many milliliters do we have? Total? How much of the acid do we have?
60.
So it's 60 total, right? We added 10, alright. So that would be 0.06 liters, right?
Yeah.
0.06, alright, and then 0.004 divided by 0.06. So if you do moles per liter to get molarity, and then you do it again here, it doesn't matter, because it's a ratio. So, you really don't need to convert it. So anyways, hopefully that makes sense. When you do the Henderson-Hasselbalch equation, pH equals 4.74 plus the log of 0.001 over 0.004, you get 4.14. That is the correct answer to this part. So, how I'm going to do it this year is exactly what we just did, so I want you to do this on your homework. As long as you're in this region, just use that equation to get the pH. I'm going to explain now how do we get the pH in this region, how do we get the pH in this region.
Oh no.
All titration questions are going to ask one of these three areas. They're either going to give you a little bit of base, enough to get to the equivalence point, or too much. So we're going to do all three examples here, and then you're going to have homework practicing the exact same thing. Then I'm going to do it again with weak base, strong acid. So it's the same process, just opposite as far as strengths. So we'll do one thing at a time. So there's that problem. All right, now, I shouldn't erase the equation. You know what? I'm actually going to give you some time to see if you can take what you learned and apply it here. So now the question would be, calculate the pH at the equivalence point. So part C would be calculate the pH at the equivalence point. Now, when I say equivalence point, Ben, what does that mean?
At 9. So
Yeah, as far as like how would you set up your ice table?
both the H pluses and OH minuses would be equal.
Okay, good. Yeah, so your moles of acid will equal your moles of base. Right? So that's the equivalence point. So feel free to work with somebody. Set up your ice table. Instead of 0.005 and 0.001, you should have the same number of moles of both, and then fill your ice table. So we know it's 0.005 moles of your starting acid. That doesn't change. So go ahead. What is the pH at the equivalence point? And again, equivalence point means moles of H plus equal moles of OH minus, or moles of acid equal moles of base. So go ahead. Take a few minutes, see what you can do. What's on the clock, Cal?
Time.
thought you kept looking at it like there was something weird on there. Do you two register for AAU yet? We might, we're gonna try and get the sports boosters to make you pay for that. Pay for like the fee. I don't know, did Nate talk to you guys? You didn't go to the meeting,
I was at the meeting.
did you go?
No, I wasn't there.
Cause you have to pay for your registration, I forget how much it is.
It's
but-
not a lot, it's like $14.
Yeah, it's like 14 to 16 bucks, and then,
Actually,
I'd rather
pay for like the rest and stuff, so we have to pay for that.
Yeah, I'd rather have to pay for that.
yeah, but the league fee too, anyways, I guess he'll let you know what's going on.
Alright.
We're gonna try and get the boosters to pay for some stuff.
$14 card.
Who plays the moles of OH minus .0052?
Say it again, sorry.
Is the moles of OH minus .0052?
Well, I'm just gonna kind of be a jerk about it and say this. At equivalence point, your moles of acid will equal moles of base.
So, yes. That's a no.
Go ahead, do it.
Yeah.
Just go with it.
I
What's the
don't-
worst case? You get it wrong, whatever. Let's go.
Yeah. We're already.
If moles of acid equal moles of base, and you know the moles of acid, then it has to be, yes. Moles of acid equal moles of base.
Yeah.
Walk by that every single day. So you never stop. A month ago. There for what?
Yes. Yeah. No, it is.
That was just a good one, because we're gonna get rid of all of that. That doesn't keep the bike pipe.
So notice how there will be no buffer. Why? What's not present? What part of the buffer is not present? The acid is gone. It's completely reactive. That's why your pH spikes. The acid's gone. Are you stuck now that, so you guys did this, right? And then now you're stuck with this?
We think we got it.
And now how do you get the pH from that?
We're not gonna tell you, but we have an answer.
Oh, alright. Go ahead, what's your answer? Is it close to 9?
pH.
Sure is, it's not.
Nope.
No.
Remember, it's gotta be close to 9.
That's what I thought.
Oh, Trevor.
Yeah, I'm back.
We